Hey everybody, this is Larry. This is day 18, 19 of the Legal Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm as the farm is loading. Yeah, seems like we're having a similar problem. We've been talking about it every day. I don't know how much of it I'm repeating. Let me know in the comments if today is going to be a little bit short, just because how many times can I talk about lexicographically smallest, days in a row, right? If you are struggling or if you have questions that and you haven't done the last couple of days, well, do the last couple of days. I feel like it'll be the same thing or similar practice anyway. So, okay. I don't know what this problem is about. I just saw the cave lexicographic go string, so let's take a look. Today we have 1415, the cave lexicographic go string of all happy strings of length n. Okay, what's a happy string? There's only A, B, and C. They're not equal to all of them, or they're not equal to the adjacent values are not equal. So, for example, strings A, B, C, right? Okay. I think this one is actually kind of interesting. I think it does require a bit of thinking, right? So, but I don't. I mean, it's not. Oh, n is only 10. Okay, well, maybe not that much thinking. 10 if n is equal to 10. Which one is n? Oh, n is length and k is the cave longest. Well, what I was going to say is actually that what I was going to say is that you can actually enumerate it in a very straightforward way, even if k is very large, I believe. And maybe I'm wrong, we'll see. And maybe we'll upsolve it a little bit. Given that n is equal to 10, there are really not that many things we have to do, frankly. Even 3 to the 10 is not ideal, but fast enough, right? 3 to the 10 is not ideal, but fast enough. What is 3 to the 10? Like 2,000 or something? No, more than that. 59,000. What am I? I'm thinking of a different base. But 59,000, which is going to be fast enough, right? So if you have any questions, just do the 3 to the n, which means try everything and then just count from k. And you don't even have to go that far because k is only 100, so you'll probably be done pretty quickly. Am I trying to upsolve this? Maybe a little bit. So the key observation is note that if s sub I is not equal to s sub I minus 1, going a little bit backwards, that means that there are only two choices, right? Because if you have A, then the last ladder. Well, let me step back for a second. So let's say without this constraint, then we have a base 3 number, right? You can think about it as base 3 because ABC, you could think about ABC as 0, 1, 2, then now you have a base 3 number. However, there is this constraint, right? But as a result, note that note that it only eliminates one choice every time, and it's not obviously the choice eliminated depends on the previous character, but that's it, right? So that means that in theory, if you kind of think about it in terms of just writing out the number of possibilities, and there's only 10, so it's not even that much, and these are underscores, so you can't really tell how long they are. But yeah, that means that the first character, how many choices do you have? Well, you have 3, right? Because it could be A, B, or C. And then the second one, it doesn't matter, or it matters which one it is in terms of it determines the next character, but there are only 2 choices after that, right? So every other thing after that, and you could kind of extend it to 2 after that. But that means that I mean, you have to be a little bit careful in the math, and I definitely am pretty bad about it. So maybe because I wrote it this way, but you can probably think about reversing it. As long as you kind of do the math right. And what I mean by that is that you could reverse it into like a thing here, and then this makes it easier to maybe work with respect to get, okay, what is the first character? What is the second character? There's a little bit nuance here though, with respect to, I know that I said a base 3 number, and that's a little bit, it's correct, but easy to also confuse yourself, because the thing with a base 3 number is that, you don't usually write out the leading zeros, but in this case you do have to, we were talking about ABC, or like, if you do zeros, AAA, AAB, AAC, dot dot dot. In this case, technically this is 0, this is going to be 1, this is going to be 2, and you may even think of it as 002, but you may also think of them as 2, but that gets a little bit confusing, right? But that's fine. Anyway, my point is that because of this here, we are able to construct, well, the the string very easily, right? What does that mean? That means that for any number, and I don't know, you could go one or the other. It doesn't really matter how, for now. I mean, it matters in the sense of lexicographically short, this kind of thing, but in theory, it doesn't matter, right? And what I mean by that is that, okay, let's say you have a number that has these constraints. So the first digit could be 0, 1, 2. The second is 0, 1, binary digits, and so forth, right? So maybe you can have something like 0, 2, 1, 0, something like that, right? And what does that mean? If you translate it, then maybe the first character 2 is just a C. 0 means the first of the remaining 2, which is A or B, right? A. And then 1 is the remaining of B and C, because you cannot duplicate the previous A. So then this is C, and then this is C. Sorry, I didn't even think, so this is actually wrong. This is B because it's AB, right? And then this is B, 0 is going to be A, 1 is going to be C, right? And so forth. And of course, this depends on, or each character depends on the previous character, but it's still uniquely determined, right? Because yeah, there's no other way to construct. I mean, okay, I didn't finish it, so let's just cut this off. But this uniquely determines this character, right? And just to kind of give you an example of how it can look different, is that, okay, so let's say if the prefix is this number instead, then it actually would be, okay, this is B, this is A, this is still C. I guess, okay, this is maybe not a great example because it actually is mostly the same, but you can even try the previous one, the final one, I suppose, where the first digit is 0, right? So that means that this is going to be A, and this is going to be B because it is the smaller of the 2 digits. This is going to be C, and I guess the rest is going to be the same. But you can see that the prefix is a little bit different, right, as a result. And I guess if you have all zeros, it'll be a little bit different as well, right? Because if you have all zeros, then it's going to be just A, B, C, B, C, B, C, B, C, right? Or some, wait, no. A, B, A, B, A, B, A, B, A. Yeah, right? So that would be yeah, just to kind of give you another example, is that if you have a 0 string, then it's going to be A, B, A, B, A, B, A, right? Kind of thing. So anyway, the reason why this part is important, or at least applicable to us, is because then now we can just convert the K to this number and then map it to find out what a thing, right? And yeah, and there are a couple of ways you can probably do the math in a better way, but the way to think about it, right, and this is tricky, a little bit tricky. I mean, if this is all just binary numbers, I think a lot of us have done it before. If not, then take some time to solve that part, to figure out, transferring from the kth number and a binary number and so forth, and kind of just throw it out, right? But because there is a 3 in the beginning, maybe there's a better specific way. But the way that I would think about it is just going, okay, well, if there's a 0, let's say we want a 2 in the beginning, right? Well, I mean, I don't know. There are a number of ways you can think about it. But let's say we're doing K, then we go, okay, well, is the first digit a 0? Well, if the first digit is 0, that means that, and let's just say we have n characters, right? Just to be clear, it does matter. So if the first character is 0, that means that we have n minus 1 binary numbers, which means that this ranges from 0 to, or it takes care of the first 2 to the n minus 1 numbers, right? And then now, the same thing, right? And this is the second one, right? And then we just kind of figure out, you write it out, then, and you just figure out, okay, well, which one does K belong to? Well, if K is the first 2 to the n minus 1, then it would be the first digit is 0 and so forth. Yeah, and then the rest are just binary numbers, so it actually becomes even easier, right? So, okay, so that's basically what I'm going to try to do, right? That's the strategy, that's the thinking, and that's the thought process, hopefully. As I said, let me know in the comments if whatever. Yeah, what was I going to do? Sorry, yeah, okay. right? So yeah, so we have, okay, so we're given n. So here we go, okay, let's, maybe there are a number of ways we're gonna do it, but I'm just gonna just write it out, right? In this way. So for, okay, maybe I'll just write if statements because they're in 3 cases just so that I can illustrate to you, because I think sometimes for loops look a little bit confusing, right? But yeah, so if k is less than or equal to 2 to the power of n minus 1, right? And I have to be a little bit careful actually, because I think it actually is not this, it's this, right? So if this is the case, then we just then answer dot append, let's just say a, right? And then maybe we just write calc k, right? There's a little bit of, just kind of make it a little bit simpler. I don't know. Maybe you don't even need it right that way. Fine, we won't write it this way. You don't need a helper on this. And then else. I mean, I want to write. You can write else if for sure, but what I wanted to do is something like the. Well, if it's bigger than it, then we just subtract it by this thing and then do it again, right? And this is why I had a for loop, but I don't know if this is clear or not. Maybe I think that way is a little bit clearer, but it's a little bit yuckier if you ask me. So yeah. So anyway, so then you have this, right? Less than times 2, right? And then that would be a b, right? Except for we want to subtract it, so then we can kind of handle the rest of it. Else, we know that it's going to be a c, and we subtract it by this thing, by 2 times this, right? And then now we have k. K is now a binary number, right? And with that binary number, we can just kind of, well, yeah. The only thing that's a little bit weird about this particular thing is that usually, but not because they map 1 to 1, you can just like take digits from left or right, it's fine, right? But for this one, it is a little bit awkward in that you do only want to go from most significant digit to least significant digits because well, each digit depends on the last answer, right? So yeah. Yeah, I mean this is actually annoying to write as well, but it's fine, right? Maybe because I'm just still being a little bit lazy because I want to go through the concepts and not the code, at least for this particular one. So I'm just going to do this, right? So then now for I in this, where I is, well, I guess C maybe, or X, I don't know, X, right? And then now we have X, yeah. So then now for maybe for something like this, we increment it twice. We want to increment it the number of times that x is, and x is going to be 0 or 1. So yeah, so okay, so we start with current is equal to a. If current is equal to the last thing, then we increment. Okay, let's just do this, right? 0, and then we increment, right? So then here, this is either 0 or 1, right? So if 0, this for loop doesn't happen, which is actually a really awkward way to phrase it now. But yeah, it's okay. So then if x is equal to 1, maybe, then now we increment again. So then we, oh, actually, yeah, that's fine. We increment again, and then if this is equal to the last digit, we increment again, right? Yeah, keeping in mind that of course, only one number can be equal to the previous number, right? Oh wait, I forgot that this is this is a character and this is a number, so it's this is just so annoying to write. Okay, in here instead, I guess let's write 0, 1, 2 to map to the characters, and we'll just translate them later. But yeah, keeping in mind that if this is the case and you increment, this can be true again, right? So that's why like it looks a little bit awkward, because if this is not true, if this is not true, then current is equal to 0. So then you can increment without checking. But then after you check, you have to do this again, right? So they're kind of like that. And then yeah, answer.append current, right? And then now we just have to convert it back to ABC. So now we have ABC. So we have join x for x in answer. And that's it, I think. Maybe I have a little typo. Who knows anymore? Oh, maybe just wrong. Well, this is always well, I messed up anyway because I meant to yeah, I mean this should be a binary number, but even for a binary number, what I'm doing is wrong because of what we said about leading 0. So this is actually pretty bad. And oh, this n is here. Okay, that n is fine. But yeah, this is actually should be I mean, we need to convert this. I just did it this way because I thought it would be easier to write, but it turns out that I'm very wrong. But they're all binary digits, so yeah. So maybe we can write something like so for offset in range of n-1 all the way down to 0, and then x is equal to is okay, fine. X is equal to int of I don't know, what's it called? Offset. Okay. Alright, this part may be a little bit too magical, but okay, fine. Right. Yeah. Something like that. Still wrong, huh? Why do I have extra characters? Did I off by 1 by accident? It may be off by 1 by accident. Oh yeah, because n-1 to 0 would have n characters, so this is just off by 1. Okay, so this is good. Why is expected? Oh, okay. So I guess it's not possible. So we have k left over, then it is not possible. So yeah, I mean, we can do a check statement here actually, because I just assumed that this would be the case, but actually, yeah, you should, if impossible is possible, then we just have to do something like this. It's a little bit yucky. That's why I wanted it for loop, but it's fine. We're a little bit late. Okay. Did I morph by 1? Oh yeah. This is k is one indexed, so we just have to do that. All right. So there you go. A lot of random little weird kinks we had to work out. But I guess we could give it this for now. But it seems to be okay, right? Yeah. Let's give it a submit. Oh, 1 submit. Ooh. Oh no. Oh no. I mean, this is clearly wrong. So maybe I had some silly mistakes, but yeah. So let's say we have 10 numbers. We have the first number, 2 number, 3, and then let's just run it. I guess I could have checked for that. I mean, this should be wrong if this is wrong, right? So, okay. So it just turns out that this thing is just way wrong because it just keeps on giving 0. Oh, damn it, Larry. I'm just I'm annoyed, not because I'm wrong. I mean, maybe a little bit, but because when I was writing this, I was like, oh, you have to fix it, Larry. Remember to fix it. And then I just forgot to fix it because before we had a string, and that's why. But yeah, that's kind of the silly mistakes that I find more annoying, because I was looking for it. I was like, all right, when you finish writing this, because this turned out to be a little complicated, but when I was writing this, I was like, okay, Larry, remember to, and then I just forgot. I don't know, maybe this is the part of being old, is that I know what I needed to fix, and I was looking straight at it and I still forgot. That's a little bit sad. But in any case, yeah, I just wanted to kind of show another way of doing this problem. And the thing is with this way is that it applies to more problems as well, or more difficult problems. So definitely play around this idea. And of course, now that you have this idea, the constraints are actually like really low, right? Because it could even go up to 1 billion and you still get the right answer, or whatever. Or I mean, even higher, really. But as high as you want, really, as long as you have memory for it. It's linear in the size of the input, and which is all of the number of bits in n. I guess not n, the number of bits in k, more specifically. N is, I guess, a function of the number of bits in k. But anyway, that's all I have for this one. Let me know what you think. Yeah. Let me know if you have any questions. And please, take care. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.